Welcome to Reimagining Cyber. My name is Tyler Moffitt. Today, we're talking about something that's quietly becoming one of the biggest challenges in cybersecurity, deepfakes and the rise of biometric bypass attacks. Joining me today is Tom Tovar, a longtime leader in the cybersecurity and mobile space, and someone who's been raising the alarm about this exact issue, that facial recognition, especially on mobile, was never really built to be a true security feature. Tom, welcome to the show. I'm really excited to dig into this with you. Why don't you give us a brief intro and background?
First of all, I'm very excited to be here. Thanks. And thanks to everyone out there who's listening to the podcast. And I think it's a great show and hope to contribute to it today. Yeah, so my name is Tom. I'm one of the co-creators of a cybersecurity company called Appdome. We use AI to code security into mobile applications. I am a hacker. I am a researcher. I'm also a mobile developer. I tend to approach hacking as a developer would. So I tend to look at how things work, how things talk to each other, and so forth, which I think these days, certainly on mobile, that's how you have to do that job. And I'm just fascinated by this whole topic of deepfakes and what it takes to bypass face recognition in the authentication flow. Yeah, so I'm happy to be here. Talk about it.
Yeah, thanks for coming on. And let's actually dive right into it. Deepfake identity bypass. How would you explain that to the general audience?
First things first is I think that facial recognition or biometric authentication was really initially designed as a convenience feature for users to get past username and password. So today we use biometric authentication as a way of generating autofills into applications. So autofilling username and password data into applications so that we can get into them very quickly, seamlessly, easily, and so forth. And facial recognition also has grown in the regulatory environment in some areas where you have to actually compare the biometric representation of a human against some stored value, say a government ID, driver's license, passport ID, or something of that nature. Along that journey, the technology has gotten really great. Vendors are out there using AI to map the face and create thousands and thousands of points of measurement within the face. We call those embeddings in the face to be able to determine the difference between you, Tyler, and me, Tom, and so forth and so on. And so the technology has really evolved and it's really gotten really cool and really awesome. The challenge with it, however, is that it doesn't take into account the rise of AI simulations of faces, and not so much from the standpoint of comparing image to image, because the same AI models used to map the face in some ways are the same AI models used to create a fake version of a face. They really didn't consider how those deepfakes were going to be injected into the process. And because of that, I'm going to go out on a limb and say there's not a single facial recognition system on the planet today in mobile that's not vulnerable to deepfakes. And that's the big scary moment right there, that no matter what you use, whether it's local authentication or biometric prompt, iOS and Android, or you use a third-party facial recognition system, there's essentially no system out there that's immune to deepfake attacks.
So all of them, every single one out there, if it calls to use facial recognition as an authentication, you're saying it's vulnerable.
Yeah, it's vulnerable. It's vulnerable for a lot of reasons. So inside mobile applications, every mobile application has functions for everything, functions for authentication, functions for payment, functions for password reset, functions for basically everything that an application needs to do, to call data and download something, to put something in your checkout area, to purchase something, to send something, and so forth. So all these things have functions, and those functions call out to services. And those services can be operating system level services or application services inside SDKs or some other API or something along those lines. Imagine, if you will, a scenario where an application calls out to an external process, okay, say a facial recognition process, and an attacker sees that function and attaches itself to that function and just returns the value that the application expects to get on a true facial recognition validation. So in other words, the vendor, the facial recognition vendor, never even sees the call. The attacker just intercepts the call and returns a success signal to the application and basically enters the application. long before there's any deepfake, long before there's any replica of the real user, the attacker just interrupts that call out and sends a signal back to the app that says success. We're good to go.
So in that scenario, there is no synthetic creation of the fake person to identify. They're just saying, oh, it was given, it was authenticated. They're not even giving that value.
Yep, exactly. So now imagine as a third-party facial recognition vendor, you have no defense to that because your service never gets called. Your service never sees the request. The attacker has intercepted that request and just returned the value to the application, and then the application opens up.
How common is that?
That's the easiest one. There's all kinds of tools that allow you to do that. You can use Frida to do that. You can use all kinds of frameworks to do that. Let's go a step further. So let's assume that you block that. Let's assume for whatever reason you're able to detect that. The second thing that the attacker does is it says, okay, so I cannot intercept the outbound request, but what about the return value from the service? There's a variety of ways that you can do that. The easiest thing to do, it's a localized attack, but it's the easiest thing to do, is just modify the app to always open no matter what the response is. So if the app doesn't have an anti-tampering mechanism or doesn't have RASP or something like that, you can just change the app so that it always opens up regardless of whether the face recognition is successful or not. Or you can hook to the function that returns the value from the external provider. So now you're not hooking or patching to the application callout, you're patching to the internal service that's returning the value and basically spoof the answer. Okay, let the authentication happen, pass or fail, but when the signal comes back, just grab it and then change it to whatever value you want. So that too is another way that people are bypassing the facial recognition process.
And those two are very common, and they're not even leveraging really AI here to synthetically generate anything.
Exactly. Now, let's go to the fun stuff. So now let's go to a scenario where you want to use an AI attack. There are third-party face recognition vendors that operate on what I call a single match process. Okay. So within a live stream, your face going through an authentication flow, the system on the back end is looking for a match value, right? My face compared to my passport face, right? If you imagine that. So what deepfake attackers have realized is they can interlace the video stream that is being sent from the camera with still images, AI created still images of the victim, and put that into the stream essentially so they're doing a live stream of themselves, i.e. a non-AI video, but inside that they are interlacing a still frame AI images of the victim. And that can bypass a facial recognition process.
Like how frequently do you need to put the frame in?
It differs depending upon the solution out there. We operate on a single match system. So as long as you are within a liveness variable, because remember, liveness has to have a tolerance level. Liveness cannot be, so you have to have some variable.
It's defined somehow.
Yeah. Within that tolerance level, you're throwing still images in there. The system is figuring out that you're live because the attacker's moving their face or moving the camera widely. But as long as there's a match, boom, you're in and off you go. So the one above that is using what's called a virtual camera and combined with what's called a face swap app. So you take an application and let's say you grab a certain amount of images off of LinkedIn or social media profiles or whatever, and you create a deepfake video of me, and I'm the victim in this case, and you're the attacker, Tyler. You would essentially take a video of yourself using a face swap application, put my deepfake image over you, okay, and then use a virtual camera to stream that
like OBS
into the biometric. And again, you're off to the races. So in those scenarios where interlacing a still AI image is not going to do it, you can also stream an AI dynamic image to a facial recognition backend and achieve a valid response, right? So that's the next level up above that. So all of these are very common attack scenarios There's definitely ones above that. The attackers are using everything from when the camera, for example, records an image, the image is often stored in a buffer area. So attackers are going in there and throwing deepfake images in place of the actual camera, throwing that into the buffer, or they'll write it to memory. The camera or the process, the third party process will write the image to memory so that they can do the compare. And the attacker will go and do a direct memory access attack or something like that and replace the image there with the deepfake image.
In real time, they're
In
able
real
to.
time. In
It's
real time.
wild.
There's quite a bit going on in the space. Now, I like to say, so wait a minute, Tom, you're not talking about the face recognition provider detecting the deepfake. Personally, I don't think they can. I don't think they can. I think that war right now, the advantage is with the attacker. I don't think that the defense technology has gotten to the point where it can detect a very sophisticated AI. Simple ones, yes. 2D ones, maybe. There are some out there that are quite good at that. But all of these attack vectors, the way that the attackers are getting those deepfakes into the process is they're manipulating the areas of trust within the operating system, within the frameworks of function calls and how mobile applications run and the processes that rely on processes and so forth. There's a tremendous amount of trust inside the application. And so if you can spoof that, trick that, whatever, there's some really interesting things that you can do.
So it looks like four main ones there. The trick it to where it's calling out and you go, oh, you're good. It's all good. Or you can sniff the coming in correct value. Or like you said, you can put a still in the authentication and apparently just one frame seems to be good enough or whatever tolerance you said. That seems crazy. That works.
And then the face swap, then you use dynamic
Yeah,
face. And then on top of that, you use buffer overrides or direct memory access attacks and things of that nature. There are others, by the way. There are others. There's
sure.
30, 40 of these. But so we have looked at some facial recognition systems that rely on that, for example, that have other, most of them are SDK based. So a lot of them, for example, will store their biometric values inside of an open area in the operating system called shared preferences, or it is user defaults. So all of the tokens, values, session keys, variables,
Sure.
etc., will be there in the clear inside the application. So the SDK gets the call that goes out and does everything. And while it's doing everything, it's just throwing stuff into shared preferences. Shared preferences are an open area. Any attacker can get to those. So the attacker can basically use that to spoof the signal.
How
going in.
vulnerable is that shared area? Is it like as
Yeah.
easy as reading
Oh,
a
yeah.
text file?
Yeah, exactly. It's kind of like a, I don't know, public parking lot for everything, basically.
That's wild.
The other thing is some of these third-party facial recognition systems don't protect the connection between their SDK and their backend. So classic man in the middle. Classic man in the
Sure.
middle.
That's what you'd expect.
Happen, yeah. So the list goes on and on about they're really not currently hardened or shielded in a way to make sure that infiltration is not possible. So there are other things. There's certainly video injections that happen all the time. There's sometimes the comparison method is stored on device. Can't tell you which vendor that is, but that one is a silly one. Another attack vector is, so let's say, for example, you're going up against a really strong face recognition system armed with AI and millions of embeddings, blah, 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 blah. Okay, fine. And let's say the tool that you're using to create the deepfake image is not as precise as the tool that's used to scan the face, right? So the tolerance level
Sure.
is out of sync. So what the attacker does is it says, oh, okay, I'm going to go modify what's called the embeddings or the encodings of the face to give me the tolerance that I need for to use this lesser quality video
So you
stream.
lower the source quality.
So you lower the source quality. No, you lower the value to quality to allow the lower source quality to match.
Gotcha.
They have scenarios out there where they've demonstrated that as well. So all of these things can be detected. All of these things can be stopped. The hard part is it has to be done within the application, not within the facial recognition process. Because
Gotcha.
once the call is made out and the call is coming, once that process is initiated, the attacker's already in position to do whatever they want. So what I typically tell folks is if you're looking to protect face recognition in your mobile application, you have to be thinking about a perimeter defense
In the
around
app.
in the app around that process. So before you call it, before you initiate the call out to whatever third party face recognition system you're using, you need to be able to detect whether the methods of deepfake attacks are present. If they're present, don't do the call out because then you're at risk, right? If they're not present and it's safe, then go ahead and do the call out and get that user on board and so forth.
You mentioned that this is the issue is with the apps. And so why has the industry been so slow to treat biometrics as this vulnerable, which sounds like open, fair game?
It's tough. It's a tough thing. Up until we came out with our Appdome came out with its defense model to deepfakes, there's really not any other mechanism out there to defend against this. Some of the third party face recognition vendors have done one or two things, but their entire businesses are built on matched results. I have a stored value of your face and I need to match your face and I need to determine that you're doing this in real time, that it's a liveness. They spend a lot of time on liveness and things of that nature. So I think their business models are different and they don't have access technologically into the full process of the application. They're just not in a position on the main thread, as I like to say. They're not in a position on the main thread where they can really see an attack like this being staged. They know perhaps after the fact, preemptively not. So the answer to your question is it's tough, it's difficult, it's complex, it's sophisticated. There's not open source tools out there to do it. There's not code samples to point to or anything like that. It takes a hell of a lot of research and a hell of a lot of expertise to achieve those outcomes, and that's why. And I think honestly, I think the world is waking up to it. I think we get calls pretty much every day now that says, I'm using XYZ vendor and I'm getting face recognition bypass. Can you guys help me? Like, it's waking up to this notion that, wait a minute, my face recognition is not a security protocol, it's a convenience protocol. Uh-oh, like holy moly. And up until AI came on the scene, it was definitely a security protocol. But as soon as AI came on the scene in the last 3 to 4 months, like it's just changed the game completely.
Would you say that there's a role for AI to defend against AI powered attacks?
I do think that what AI has done is it's made the learning process of creating attacks and amplifying attacks and innovating attacks and so forth, like extremely easy. Like we're talking like extremely easy. What might have taken you 5 years to learn, you can learn in 15 minutes now, just with a few nice prompts and figure some stuff out. So I do think that's happened. I also think on the defender side, at least in the context of my company, of Appdome, using AI to code those defenses into your application is a very powerful response to the attack vector. You can't give AI a blank piece of paper. Coding
Sure.
the AI is just it's like a junior developer right now. But if you have a seasoned researcher that can write the defenses, you can have AI stitch that into your application pretty effectively. It won't write the code, but with an understanding of the code, it can integrate that into applications very fast. I believe that in the next 12 to 24 months, maybe, I'll put quotes around maybe AI will be strong enough to do some basic security coding, but I think it's going to take us 4 to 5 years for it to really get there. In the meantime, using technology to deliver these defenses in apps is the greatest response that you can have to these and other attack vectors. I think in terms of using AI to detect AI, I think that's just an arms race that honest
Sure.
face recognition guys are going to have to And Apple and Google are going to have to, that's just better mousetrap competing with a better mouse. Like it's just the face
Yeah, that's
recognition.
tale as old as time.
Yeah, they're going to get better at recognizing you, and the attackers are going to get better at simulating you. And that war is going to continue. And what I would say to the face recognition vendors out there is spend your time on that, because if you're not, AI will lap you. And then it won't even matter if you block all the things that I'm talking about, because ultimately your face recognition will fail against an AI replica of somebody. So they've got to spend their dollars, they've got to spend their innovation, they've got to spend their engineering on staying ahead of deepfake to deepfake evaluations, and leave the perimeter defense to those that are in the flow on the main thread of the application, outside of their SDKs, outside of their process, looking for indications where a deepfake attack is being staged, or it's being prepped, or there's something, an external process that's connecting to shared preferences and it really shouldn't be there, or whatever. The SDK only has the view, of itself. It doesn't have view into the app, and it shouldn't.
Looking towards the future and looking to wrap this up, what's next for Appdome in this fight?
I think we're right in the center of this AI native explosion, and we're certainly looking to use AI not just to code defenses and applications. We're looking at using AI to support every stakeholder in the value chain. So everyone from the development team to the QA team, to the DevSecOps team, to the cyber team, as well as the consumer, the end user. When the consumer, let's say, for example, the consumer doesn't realize that there's malware on the device or something, how do we use AI to support that user and help them get past that attack and get back to using that app automatically? And can we use AI to automate resolutions all the way down to the end user? So now, Tyler, you're sitting in your bank app and you get a notification that something bad is going on your device. Can you push a button and automatically have an AI agent act on your behalf to remediate that threat on your device? You can get back to using the app. So we're on a mission to automate defense within the mobile ecosystem. So I think what you're going to find from us this year is leveraging our large data footprint and AI models to predict upcoming attacks within your network, to provide recommendations, and ultimately autonomous defense, basically the self-driving defense model for mobile apps and mobile businesses, all the way down to the end user. So the end user facing a threat can just click a button and resolve that on their device and get back to it. And the friction and the support calls and everything, just leverage AI at every level of the defense model to make it easier and simpler on all of us to stay safe and secure.
Well, a lot of people are talking about. Tom, this has been such a fascinating conversation. I appreciate you coming on and sharing your perspective. It's clear the attackers evolve, especially with tools like deepfake and AI. It keeps accelerating acceleration. I don't know the next 2-3 years was what it's going to look like, but we need to change the way we think about identity and just trust in general. And mobile has to evolve too. So thanks for coming on, Tom.
Thanks for having me.
Hello, producer Ben here, and we have a crop of great interviews all lined up and ready to go over the next few weeks here on Reimagining Cyber. But if you can't wait 7 days between each episode, why not plunder the catalogue of almost 150 editions of the show? For example, in episode 97, we heard from Kevin Danino, founder of KCD PR, and he was talking about crisis management in cybersecurity, i.e. the pivotal role of effective communication during cyber incidents.
I think in terms of communicating with the media, oftentimes companies will have, let's say, a news or press center page with the appropriate comms contact, but then internally having comms sort of address the issue, whether it's to the employee base and just saying, hey, here's the issue, here's who's responsible for handling it. That's where all that planning comes in handy. And then the medium of how you're pushing that out. So it could be email, it could be the intranet. If one or both of those is compromised, it could be setting up a toll-free number and having sort of a town hall. It could be reverting to texting. I mean, again, like there's going to be various levels of if one is compromised, here's the next.
That was from episode 97, called Maintaining Leadership and Credibility After a Cybersecurity Breach. Please do follow the show wherever you get your podcasts, and if you get the chance, leave us a rating and review. Thanks for listening, and goodbye.